Hello, welcome to another Teacher Tobin tutorial. We're going to be looking at topic 3, device operations, about memory essentially and how it's stored. And this is part of the Edexcel GCSE computer science course and preparation for exams, and we have some exam style questions to go through as normal. So this shouldn't be a long video. We've done some of the harder things already, and we've talked about von Neumann, fetch decode execute cycles, memory address registers, buses. That was the big thing really. We talked about ROM and RAM and primary memory and embedded systems, and we've also talked about secondary storage as well. So let's talk just a little bit more about how different storage devices might actually work. I mean, we've got HDDs, change the color, hard disk drives, and those are magnetic, and they're still used a lot. I mean, they're still used an awful lot. Okay, so they're going to have there are lots of platters here, and they're going to have a mechanism, an actuator arm for reading all the different parts on there. It's very typical for a server, which is what a lot of websites are served from in sort of rack servers and data centers, to have SSD drives, solid state drives, working in conjunction with large capacity secondary storage. It's very typical. So we might have an SSD in there, solid state drive for the operating system in there. Maybe it's running some sort of CentOS operating system, Linux, and then all of these, because they're much cheaper to buy high capacity drives, and they're often in what we call RAID arrays, so they have some redundancy, and they're still used a lot. So magnetic storage is still definitely part of the landscape. However, most devices now, most computers do not have moving hard drives in them anymore. But how do they work? So the main thing here, magnetic platter. So a magnetic platter stores data. Now you've got to be careful because it's affected by heat and magnets. So if you put it near your guitar amplifier, it could potentially corrupt some of the data, especially strong magnetic fields. So you've got to be a little bit careful about that. And if servers get a bit too hot, that can also be a problem as well. That's why they have lots of cooling fans in them, and they spend a lot of companies spend a lot of time having fancy cooling systems in there because they're constantly being whirling around. And well, how it actually works is iron particles on the disk are magnetized, and they're either north or south, which represents a 1 or a 0. I mean, technically speaking, you've got your north. You don't need to know this, by the way. You won't need to know this for the GCSE. But if you've got a south pole at the bottom and then it goes to north, that would be the 1, and then this would be a 0, the opposite way around. That's what's actually going on. But you don't need to know that in detail. But I would remember that it's got a magnetic coating that you can polarize to be either north or south, and that represents a 0 or 1. I think that's worth remembering. So how do solid state disks work then in that case? So SSDs, which are hard disks, but just be careful with the terminology there, because these mean magnetic secondary storage. There are different sizes of SSDs now. I mean, of course, they can be quite small, and USBs, and you could probably put into this category as well. You could say flash storage. USBs go into this category as well. They're also solid state. They use, let me use a red pen, they use electronic circuits. And sometimes they're called NAND memory. And again, you don't need to know what a NAND gate is. You only need to, for Edexcel, GCSE, computer science, you only need to know and or not, but NAND gates work in a slightly different way to ANDs. But essentially the way it's working is transistors. Transistors are used to control the flow of current, and if you allow the flow, that equals a 1. Block the flow of current, it equals a 0. So the main takeaway from there is all data is stored electronically on SSDs. And when we start looking at defragmentation and utility software, you'll know that we don't use them on SSD drives. It's only for magnetic storage drives, because all the data is stored electronically, and the read and write information is not really going to be affected by that. Let's have a look at optical storage then. Optical storage, which could be CDs, DVDs, and they stored about 650 megabytes. DVDs, I think were 4.4 or 4.8, and then of course you've got your Blu-rays and all sorts of other permutations of those. Blu-ray discs, which are huge now, and they use different. If that's the surface of the disc spinning around, side view, then a laser is either going to be usually looking down on it. Actually, I'll change the color of that. Laser is going to look at each little part, and then it's going to see the different wavelengths of laser it's used. CD was just one, and then dual layer video disc, they use 2 different types of wavelengths, and Blu-rays again use different types of wavelengths, and then different types of lasers or numbers of lasers to get the extra data on there. So they have a reflective surface, and the laser can either burn what we call a pit, like that, or just have like this land here, and the pit might represent 0, 0. We might have, every time we get to a pit, a 1, and then the rest zeros. So this is more detail than you need to know, but what's actually happening, as soon as that you see that little curve in the pit, that's going to equate to a 1. Okay, so that little curve, as soon as the pit is starting to be made, that's going to equate to a 1, and the rest of them are going to be zeros. I have never seen an exam question that's that detailed, but I have, and I'll show you here, there is an exam question about how optical storage is used. So it might be, I think it's worth you knowing the vocabulary of lands and pits, and that binary information is stored on the system. I think that is prudent. So let's just go through some exam style questions here. So let's start from the top. Data can be stored in different ways. Right, here we go. Describe how data is stored on optical media. So we talked just a little bit about that. So a laser, you can say heats or burns areas of a disk which create lands and pits. So not that I would draw on here, but I'm just abbreviating here, create lands and pits. And I would just put representing binary data 0 or 1s. That's more than enough to get 2 marks there. And it's quite specific, isn't it? So again, it was a real exam question, so it was worth us going through it. State the type of secondary storage that store. Well, that's easy, isn't it? Hang on. That stores data as electrical charges. So you could put SSD here, and I think they'll give it to you. But it's better to say solid state. And it's easy to remember because it doesn't move. It's a memory system that doesn't move. Optical storage moves, magnetic storage moves, solid state stays where it is, which is the advantage of it, because you could use it. I mean, I used to have an old Sony Walkman when I was at school, and that thing would constantly jog around. It's got moving parts in it. Whereas, and then the first iPods also had moving mechanical hard disks, which made little noises and also susceptible to damage from when you're jogging or running around or in the car. So of course now they're all solid state now, and you don't have to worry about those things. State the type of secondary storage that uses a laser to read a disk. Optical. Now you have to be, even though it's a really easy question, you've got to use the correct terminology and the correct vocabulary. Optical is the only possible answer for that. Explain the best choice of secondary storage for a battery operated mower. Well, a mower is something that's moving around a lot, isn't it? So as we just said, like my Walkman, it would be better to use, so you could say, should use solid state secondary storage. I mean, that is the best answer to start off with, but it is explained and it's 2 marks, so even though that's enough certainly for a mark, I want to add more. I want to make sure, and I'm going to use my classic kind of linking word there, because, and as soon as you put because in, the examiner's going to go, okay, right, how can I give you the extra mark? Because, and it's simple, right? It has no moving parts. No moving parts. You could say plus lower power consumption, and if you really wanted to be careful, you could talk about why having no moving parts would be best for a mower, because it's outdoors, but I'm pretty sure that would be enough to get you your 2 marks. So even though it's just a fairly straightforward subtopic here, there's quite a lot to unpick in terms of vocabulary, and it is worth spending a moment to put this into your own notes. And as you saw, these are real exam style questions here that could come up in your exam, so you don't want to be caught out with relatively easy questions that just require you to have that knowledge. Okay, see you in the next video.